In this video, we're going to talk about the truncus. Now, the truncus is a function that looks like a tree trunk. So if I was going to draw it on these very badly drawn axes, it would look something like that. Similar to the hyperbola, it approaches these axes but doesn't touch them. So let's start off with what we already know. Now, what we already know is that your hyperbola looks like that, basically. We know that we have two asymptotes for the hyperbola, and the asymptotes are a vertical one and a horizontal one. And that the equation of those asymptotes tell us the lines that this upward bit approaches and approaches but never gets to, or this downward bit approaches and never gets to, which is called asymptotic behavior, which is why they're asymptotes. The vertical asymptote will have an equation x equals h, and the horizontal asymptote, which is this one, where again we approach and approach but never meet in both directions, has an equation of y equals k. Now, it's no accident that I used the equations h and k, because remember, our standard equation that we like to use is this equation where we have h and k. And h and k is a special point. So if I write down special point of h and k, and when we're dealing with shapes like the truncus or the hyperbola, h and k are the equations of my asymptote. A is still the dilation. So I can write here that A is the dilation. Now, if you're familiar with all of this for the hyperbola, then we're ready to have a look at the truncus. So here we have a blank screen ready to fill with knowledge. And the first thing we're going to do is we're going to draw our standard truncus, which looks something like this. So as I said before, it's meant to be symmetrical. It's like the tree trunk on a graph. Now, the equation of the truncus is y equals ax minus h to the power of -2 plus k, or that can be written as y equals a over x minus h squared plus k. So the important factor that gives this graph its shape, which really should look a lot better than that, is this power of -2 when we put the equation in standard form. Now, if the truncus doesn't exist exactly like this, if I've got values of h and k, it'll look something like this. So first of all, as I said before, my h and k are special points. So my x asymptote, or actually more correctly, let's call it my vertical asymptote, will be at the equation where x equals h. So somewhere along the line, we'll have an asymptote that...
If you found this video helpful, please subscribe to my channel or like the video.